Hello everyone. In this video, we are going to continue with the arithmetic group of instructions. Last video we have done all instructions under arithmetic which are for addition operation. So next is for subtraction instructions. Okay, the first instruction under subtraction is SUBR. The meaning of SUBR is subtract the contents of register from accumulator and the result to be placed in accumulator. It is a single byte instruction and being operand is register. It is coming under register addressing mode, and because of the subtraction all flags may be modified. So the flag content modification is all depending upon what the data is there in register and accumulator. As we know, the subtraction is always done with the 2's complement method. As we are this part of 2's complement method we have already done in 11th standard, the same method is happening inside the microprocessor. So we need to understand कि when we do subtract R, the subtraction process is always 2's complement method in 8085 microprocessor. The register that is valid for subtraction is now A, B, C, D, E, H and L. So any one of the register can be your register R. So it can be, if you write SUBA, it is A minus A, or SUBB, it is A minus B, something like that. Okay. Now it is, as it is a 1 byte instruction, so the opcode itself gives the full meaning to the microprocessor. Okay, now we'll see one example of subtraction, means how the subtraction happens, and after subtraction the result will be placed back in accumulator. Okay, so that is what is subtract R. You can see in this one the example of subtract R, that is SUBP. That is A is equal to 0, 9 I have taken, B is equal to 0, 8 means you are doing what? SUBB is 9 minus 8. So you can see accumulator 9 is 0, 0, 0, 0, 0, 1, 0, 0, 1, that is 0, 9 and 0, 8. 4 times 0, 1 with triple 0 is 8. Now keep A as it is, take 2's complement of B. So how do you take 2's complement of B? It is replacing all zeros by 1, ones by zeros, and to that number add 1 to it. That becomes 2's complement of 08. So in this 2's complement of 08 is 5 times 1 with 3 times 0. Okay. Now whatever is the content of A, that is 09, you are adding to 2's complement of B, and the result that you get is 4 times 0, 3 times 0 plus and 1, that is 7 times 0 and 1. And there is a carry generated. Since carry is generated in 2's complement, we are going to discard the carry and we say the result is positive. Okay, so that's, you can see 9 minus 8 is 0, 1. So the answer is 0, 1. There is one more example we have seen here, the opposite of it. That is when you get the negative result. So subtract C, the content of A is 08 and content of C is 09 we have taken. All method is, everything is same. When you come to this, the result after the addition of accumulator as it is plus the 2's complement of the subtrahend. So what you get is 4 times 1 and 4 times 1, that is 8 times 1, which is not a result. 8 minus 9 should be 0, 1, isn't it? So how do you get 0, 1 out of this? You take 2's complement of this. So 2's complement of 8 times 1 is 7 times 1 with last bit as 1, which is the result, that is 0, 1H. So when there is no carry generated, the answer you get it through is getting 2's complement of the number. Okay, that is how you do the subtraction. Next instruction is subtract memory. The meaning of subtract memory is subtract the contents of memory location whose address is there in HL pair from accumulator contents, and the result is stored in accumulator. Again here also it is a 1 byte instruction and all flags may be modified. Since we are taking the data from memory and we have not mentioned any address directly here, it is coming under indirect addressing mode. Okay, so there is only one instruction, and as in the last instruction you would have written SUBA, SUBB, something like that. Here it is only memory, but memory address is changing depending upon what address you are putting in HL pair of register. So this is subtract memory. You need to write the comments, you need to write the example also. Okay. Next is SUI 8-bit data. So here you are subtracting the immediate 8-bit data from accumulator. So accumulator minus 8-bit data, the result is stored back in accumulator. Since there is an immediate data which is there in the instruction, so the instruction comes under immediate addressing mode. And this instruction is understood by 2 bytes. What are the 2 bytes? The opcode and the immediate data byte. So those two are the bytes for SUI 8-bit data to be given the complete meaning, and it is or here as you see it is a subtraction instruction, so all flags may be modified. Okay, so example also you can consider something like, see here, SUI 25H. So when you do this SUI 25H, you need to consider the content of accumulator. So I have given this for you to do for your own homework so that you understand how the subtraction happens and how are you going to write the effect of this operation on the flags. Okay, so suppose if you consider accumulator content as 24, then it is 24 minus 25. And if you consider accumulator content as 26, it is 26 minus 25. So please do the both way of addition, both the way of subtraction. One smaller number minus the bigger number. The other way also. Please do it and see how you get the answer. Okay. Next instruction under subtraction is sbbr. As we have seen SUBR, it was only A minus R. Here we are taking care of the borrow that might be possible while subtracting. So that borrow is nothing but the carry content in the 8085. So whatever is the carry content is considered as the borrow, and then that content, register content altogether is subtracted from accumulator and the result is placed in accumulator. Here the operand is register, so register addressing mode. It is a single byte instruction and all flags might be modified. Again, our valid registers are A to L except F. Again, you need to write one example. Consider the content of one register. Consider that instruction. Consider the content of accumulator. Do the subtraction, and you have to show it how the subtraction gives the result. Okay. Next is sbbm. Sbbm is subtract, accumulate memory content and carry content from accumulator. That is what is A minus memory minus carry. So when you're doing this subtraction, what easy way you can adopt is add the contents of memory and carry and then do A minus that total content. So it becomes easy. Otherwise, you need to go for 2 times subtraction. Again, 2 times taking 2's complement and all. So it is better you add the contents of memory and carry and then subtract it from accumulator. It is same as in the last instruction also, where you have done A minus R minus carry. So what you do is R plus carry, and that content of R plus carry you subtract it from accumulator. So SBB is subtract with borrow. Yes, subtract with borrow. Again, you need to write the comments and you need to write the example with explanation. Okay, the next instruction and the last instruction of uh, this subtraction part of the arithmetic group is SBI 8-bit data. Now, what do you mean by SBI 8-bit data? Accumulator minus 8-bit data minus carry. So, it is a 2-byte instruction. Immediate data is there as an operand, that's why immediate addressing mode. And all flags may be affected. So you can give an example, anything like SBI 25H. Consider the contents of accumulator, consider the contents of carry, and then see how the subtraction result gives. Okay, so this is all about subtract with borrow what? The immediate data. Okay, I, that is in the next lecture we're going to continue with the next part of the arithmetic group, which is related to increment, decrement, and double addition. And you have decimal adjust accumulator, incrementing or decrementing pair of registers. So all these instructions will be done in the next video. Okay, thank you.